Hey guys! So now that we reviewed how to graph quadratics and write quadratic equations in vertex form and in standard form, next we're going to look at how we can use quadratics to model real-life application problem. Specifically, we're going to use quadratics to optimize problems. And so for each of these word problems, I want you guys to do a couple of things. Define your variables. So what's x, what's y, if there's an x or y with two variables. Write an equation to model the problem, and then make sure you answer the question that is being asked. A word problem always has a word answer. So in the first problem, we have the rock who has gone vegan and wishes to make a garden. He's busy constructing a fence that will maximize the area. So we want to have a garden with the most amount of area. And the garden will be rectangular in shape, and he has 100 feet of fencing to use. So he's got to be able to put a fence around his entire rectangular yard, and he's only got 100 feet of fence. What dimensions will maximize the area, and what will the area be? So we want to figure out what are the dimensions of the rectangle that he can make with 100 feet of fencing. Certainly you could split it up, like maybe 40 and 40 on opposite sides, and then 10 and 10. So you could have something like this, right? But does that give me the maximum area? Does that give me the most amount of space to make a garden? Or maybe you want to try to make it closer to a square, 25, 25, 25. Does that give me the maximum area? So the question is, what kind of rectangle should we make with the 100 feet of fencing in order to get the most amount of area? And for this problem, we're going to be using quadratics. And so let's see how we can do that. Because it's a geometry problem, I'm going to start by drawing a rectangle first. It doesn't have to be drawn to scale, but just to visualize what's going on. And we don't know the length or the width of the rectangle, right? So that's our variable. That's going to change because we can make the length to be any length, and then that will change the width. So I'm going to let, for my variable, I'm going to let x equal the length of the rectangle. And I'm going to label it. So this is x, opposite sides are congruent. This is also x. So if this is x feet, okay, think about how I can represent the width of the rectangle. Instead of using a different variable, how can I represent the width of the rectangle in terms of x? If I have 100 feet of fencing and I used up x units here and x units here, what's left over would be whatever 100 minus 2x would be, right? And then with that, I have to divide by 2 to fit these two sides. So each side is going to be 100 minus 2x, 100 feet, take away the 2x I already used on the left and on the right, and then with what's left over, I'm going to divide by 2 because I still have two sides to cover. So that's going to be my width. And if I simplify this, this is going to simplify to 100 divided by 2 is 50, minus 2x divided by 2 is 1x. That's going to simplify to 50 minus 1x. Okay, so I've labeled my rectangle in terms of x, so depending on what x is that we pick, the width is going to change. And then next, the question that they're asking, which is important, the question that they're asking is, what dimensions will maximize the area? And what is the area? So we want the highest, the largest area, so let's come up with another variable. A, I'll call it A, is going to represent area, and that's what we need to find as well. What is the maximum area, right? We know from geometry that area is equal to length times width, or base times height. So in this case, my area is equal to length, which is x, times the width, which is 50 minus x, and we can come up with an equation for area. So the area is equal to 50 x minus x squared, and put it in standard form, negative x squared plus 50x. Depending on what x is, that's the formula that will help us calculate area. And so we're just using a in this case instead of y. You could use y if you want, but I'm just using a for area. And you can see that the equation that models how I would calculate area in my problem is a quadratic. Looking at my a value, it's a quadratic that opens down, right, because a is negative. So I know that if I were to graph this equation, it'll be a parabola that faces down, which means it's got a maximum. Okay, this maximum point, x comma y, in this case, x comma a, this maximum point, the y-coordinate, is going to give me the highest, the largest area, and then the x-coordinate would tell me what would be the length of the rectangle that would give me the biggest area, the maximum area, because that's the highest point in my parabola. So to figure out this problem, I just need to figure out what the vertex is. And we can use negative b over 2a. So x is equal to, the x-coordinate of my vertex is going to be negative 50 over 2 times negative 1. So that's going to give me 25. And then, so in order to get the maximum area, the width should be 25. And to figure out what the area is, when the width is 25, I just put 25 back in for x into the area formula. So area is equal to negative 25 squared plus 50 times 25, and that's going to give me 625. And so I know that the dimensions of my rectangle should be 25, and then the width is going to be 50 minus x. So if x is 25, 50 minus 25 is 25. It should be a square, I guess. In this case, a square would give me the maximum area. Okay, so to answer our question, what dimensions will maximize the area? If the rectangle was 25 feet by 25 feet, that would give me a max area of 625 feet square feet for area. Okay, and you can see that every point on the parabola that we just graphed on the right side, every point on here represents a possibility for the width of a rectangle, and then depending on what the width is, the y-coordinate represents the area. So the x-coordinate of every point is a possible width, and the y-coordinate of every point is the corresponding area depending on what that width is. And we found the maximum, which is the vertex. Okay, and then we're going to skip over number 2 for now and take a look at number 3 instead. It says the Red Line into Boston charges $2 per ride and receives 1,200 passengers every day. It's estimated that for every 20-cent decrease in the cost of the ride, an additional 200 riders will take the Red Line. We want to find a fare that will maximize the company's profit. So ride costs $2 normally, and normally we would have 1,200 passengers, but every time we decrease the price by 20 cents, we can assume that we predict that an additional 200 riders will take the Red Line. So we want to determine how much should we charge, should the fare be in order to maximize the profit. Okay, we don't want to decrease the price too much, because then even though more riders will come on the ride, we're still not making money. But we don't want to increase the price, keep the price high, because then we would have less riders. So where is that happy medium in between where we charge enough to make a good amount of money but still have enough riders? So in this case, think about what our variable would be. This one's a little tricky. Okay, what's going to change? Well, the price is going to change, right? We can change the price. And then depending on how the price changes, the number of customers, the number of passengers are gonna change. So the price, we're gonna be decreasing by 20 cents. So how many times should we decrease the price by 20 cents? That we have to determine. So I'm gonna let our variable x, represent the number of 20-cent decreases. How many times should I decrease the price by 20 cents? Okay, so 0.20. And so let's come up with an equation to model this problem. And sometimes it's easier to think about it in words. So we are looking to maximize profit. Okay, so I want to come up with an equation that will help me calculate profit. And in this case, profit, just in words first. Well, how do I figure out how much money we're going to make? Profit can be calculated by the number of riders, okay, how much money we take in, depends on how many people comes, right, times how much they pay per ticket. So the number of riders times the price per ride. That will tell us how much money we make. Just like for homecoming, how much money will we make for homecoming? Depends on how many people comes and how much is per ticket, right? So you multiply the cost of one ticket times the number of people. Same idea here. Profit is the number of riders or the number of passengers times the price per ride. And so I'm going to use y. You could use p for profit if you want. I'm just going to go back to using y because we're familiar with that variable. Y is going to represent profit. Okay, the number of riders, that's going to change based on how many times I decrease the price. Initially, we assume that there's going to be 1,200 passengers every day. But for every x, for every 20-cent decrease in price, I'm going to predict that there's going to be 200 more riders. So it's going to be 1,200 to start plus 200 more for every x. So if x was 2, there'll be 400 more people. If x is 3, that would be 600 people, okay, in addition to the 1,200 that comes regularly. And then the price of the ride initially is $2, but then I'm going to subtract 20 cents for every x, because every time I decrease the price, I decrease by 20 cents. So number of riders is 1,200 plus 20x. The price is $2 minus 20 cents for every x. And so from here, we have an equation that can help us model profit. Let's FOIL and simplify my equation to see what we get. Okay, so 12 times 2 is 24. Add my 2 zeros. And then I've got 1,200 times 0.20. That's going to give me negative 240 x plus 200x times 2 is going to give me 400x minus 40x squared. Okay, and then we're going to combine like terms and put it into standard form. So y equals negative 40x squared plus 160x plus 2,400. Okay, and so that's my equation in standard form. And then again, if you notice, this is another quadratic equation that models profit. And so because it's a quadratic, x squared, I know that when I graph this, it's going to be a parabola that opens down, because a is negative, negative 40. And because it opens down, it has a vertex. And this point, x comma y, is my maximum. Anytime you want to maximize anything, you're always looking for the vertex. So keyword here, maximize. You're looking for the vertex, the highest point. This x coordinate will tell me how many times I should decrease the price by 20 cents. And then the y-coordinate of that point would be what is the most money that I can make out of this situation. And so let's find the vertex. I want to do x-coordinate is negative b, so negative 160 over 2a. Okay, so that's going to give me positive 2. 2 decreases. That means I should decrease the price by 20 cents twice. Okay, and the question is, find the fare. How much should I charge? Well, if I decrease it by 20 cents twice, it's going to be minus 40 cents, so $1.60. And you can actually get that by plugging it back in to this expression, 2 minus 0.20x, because we defined it as that's the cost per ride. Right, so over here, to find the cost per ride, we're going to do 2 minus 20.20 times x, which I now know is 2. I should drop the price by 20 cents twice, and that's going to take away 40 cents, and so we should charge $1.60. Okay, and that's what the question is asking. Now, it doesn't ask you to find what is the maximum profit, but if it does, you can figure it out, right? If it asks you what is the most amount of money that the company can make, you would put 2 back in for x and solve for y and go from there. Okay, so today for the rest of class, you are going to do some practice on similar problems. So I want you guys to work on the next page, 2.2 practice. I would like you guys to do numbers 1, 2, and 3.